In this module, we're going to look at integrating with the WCF Line of Business Adapter Framework. In Lesson 1, we get an introduction to the WCF Line of Business Adapter Framework and what it provides and why it's important. We'll then see in Lesson 2 how to create an adapter using the WCF Line of Business Adapter Framework. And in Lesson 3, we'll look at the BizTalk Adapter Pack. This includes a set of adapters that Microsoft has built with their partners on top of the WCF Line of Business Adapter. So you'll see what you can do with it, and then you'll also get a chance to see what Microsoft has done to enable some common line of business applications. In this first lesson, hopefully we'll give you a sense of why you might use the WCF Line of Business Adapter Framework, give you a sense and an understanding of what that framework is, and we'll learn all about the outbound adapter architecture as well as the inbound adapter architecture, how you can write code to receive messages or send messages. And we'll finish with a demonstration that shows how to consume a service that's been exposed using the WCF Line of Business Adapter. The WCF Line of Business Adapter Framework is really focused on service-oriented architectures, where you want to take an existing application or a database and you want to service enable it. You want to make it look like a web service. Now you could do that by simply creating a loosely typed service, one that simply takes in raw XML and parses through that and does something. You could also build a strongly typed service with a set of operations and then plan for versioning, as the database structure will probably change or the application interface may change. You may need to add new methods as you go. So in version 1, you may only support a limited amount of functionality from your application or your database. And in version 2, you want to support more functionality. You're going to add new operations. You need to plan for that. Or the third option is build something that automatically exposes metadata. Build something where at any time I can use that service itself or the wrapper to find out what operations are available, what can I call, what messages should I send, and what should they look like. And that's really the focus of the Line of Business Adapter Framework. The Line of Business Adapter Framework comes with a software development kit or an SDK that provides a mechanism for you to expose existing application functionality as a WCF channel or service. And so we layer on top of your application WCF, and then on top of that, the adapter SDK is layered. And the goal is to simplify the task of building your service and building that dynamic metadata API that you want to expose. You want to allow people to find out what operations are available. So it provides a more streamlined model, right, both for WCF as well as for your system. It provides you a simple integration layer. And now, when you've created an adapter based on this SDK, it allows you to integrate with any application that can consume WCF. Now, that might be the WCF Custom BizTalk Server Adapter. It might be a .NET client. And you may also take this adapter and host it in such a way that a Java client or any other client would be able to call it using some of the open standards and basic HTTP and SOAP messaging. If we look at the outbound architecture for the adapter, you can see that we start with BizTalk or some other application. It's going to create your adapter, which essentially is going to be a WCF channel. The WCF channel model wraps the adapter framework, or the adapter framework rather plugs into that channel model. And of course, the adapter framework then can call your custom code, which knows how to interact with your line of business system or database. So the client, in this case BizTalk or some other application, sees the WCF API. It can then send a message through that. The adapter framework takes that message, hands it over to your custom code, and your code then can take that message, pull it apart, find out what it is you're supposed to do, pull out the relevant data, and invoke operations on your API, call stored procedures, or insert data or retrieve data from your database. The inbound architecture allows for BizTalk or other applications to listen for or wait for messages from your line of business system. And in this case, your custom code is responsible for listening or monitoring or polling that line of business system in some way, gets notified that there's relevant data that needs to be pulled out. And so we can now pull that data out. It gets handed off to the adapter framework, which gets passed up through the WCF channel system, and a BizTalk application or other application can be listening for that message to come up out of the WCF channel. So you can host a service in your own .NET application, or you could use a BizTalk receive adapter to go out and monitor essentially your system for those events or those messages. In this demonstration, I'll show you how an adapter created with the WCF line of business adapter SDK is consumed. And you'll see that there's a consistent user interface, a consistent model for interacting with adapters built with this framework. This example will be looking at consuming a line of business adapter that we have here in our solution. So we've got a custom adapter built out here within the solution. And what I'm going to do is go to this client application, and I'm going to indicate that I want to add an adapter service reference. This means I want to consume a service, or really an adapter, that's been exposed as a service. And if I look in the bindings, you'll see that because I've got the BizTalk adapter pack installed here, I've got a couple of Oracle bindings, one for the database and one for the e-business suite. I've got an SAP binding and a SQL binding. Then I have this NW binding or Northwind binding that's a custom binding that I've created. That's the other project here. Now if I click configure on here and go to the URI, you'll notice that it wants for the URI a data directory. So I'm going to give it see all files. Oops, let me get that right. See all files, demo code, and we'll put in module 16. This is where we're going to find for this particular adapter, it's going to use that directory information. It's going to look there. It has a couple of XML files that it uses to store discounts and surcharges. And so it's going to use this information in its URI to go and find those files and to be able to load those up and use those at runtime. Now if I go to the binding property, you'll see that I have a cache duration in minutes. I'm going to change that to 15. That's a specific setting that's been exposed by this adapter. It allows me to further configure it and give it additional values that it can use to control its runtime behavior. The rest of these things, the name and the timeouts, are all standard binding properties that are surfaced by all of the adapters. So we'll click OK there, and I'll choose to connect. Now you'll notice I've got two different contract types that I can do. I can do inbound operations or outbound operations. If I select inbound operations, this would be where I want my application to sit and receive events from the adapter. You'll notice I don't have any that are exposed here. That's because this particular adapter doesn't support that model. It does support outbound operations, however, and I can see that there's two categories over here where I can list discounts, or if I look under surcharge listings, I can list surcharges. So you can see that through browsing, I can find each of those different types. So I'm going to look under the surcharge listings, and I'm going to have this list surcharges. I'm going to add that in there. Now, browsing is one way that we can find these items, but we can also search. So if we go here to the discount listings, I have this search box up here. So I can type list and search. You can see I can find just the list discounts. If I go up to the root level here and look, I'll see both list discounts and list surcharges. Those are both available now at this higher level scope. So as you change scopes and in here, and we do the list, You can see the scope is applied up here at the top when we just get that item. Now again, if we choose the whole category, then we get both of those. So we'll add the list discounts this way into that particular item. And we can also get some advanced options in here. So when we generate this adapter service reference, we can do things like asynchronous methods. We can enable data binding for these items, work with other types as iXML serializable, and even choose the serializer that we want to use. These are all WCF options here. So we click OK, we'll add that in. And if we go now to our window, you'll see that we've got some generated code here that was created with all of our pieces in there. So we can see we've got a client here, Northwind client. We've got requests and response for each of those operations. Let's go to our window code. And we'll just uncomment some of this code. We'll see that when we click one particular button, we're going to go out and use that client that was just generated. It's going to use some configuration from the configuration system about how to connect. And then we're simply going to call a method on there, on our proxy that we just created, to go and get the discounts. And we'll then take that list of discounts and set that as the data context for a list box. And down here we'll do the same thing for the surcharges, and we'll update that application. So let's set this as our startup project. When we run the application and we get our user interface, if we click get discounts, it's going to call to the adapter. The adapter is going to go load its XML files, find the discount information, and then it's going to give us back that list of discounts that we have. If we call get surcharges, much faster now, everything's been initialized. Get discounts, it'll be fast again as well. So there's our different surcharges that we get as well. So the application was able to add a reference to that. It generated for us this proxy class, making it very easy for us to go out and consume that. And if we look in the application configuration file, we'll see the binding information out here, various settings, and we can see our cache duration that got created out here as well with 15 minutes. And it was able to go out and use that information to call the application adapter and consume data from that. In this lesson, we'll see how to create your own WCF line of business adapter using the SDK. We'll take a look at the adapter project template that you can use from Visual Studio, and then we'll look at the mechanics of how you come up with a URI for your line of business application, how you manage connections and read the configuration. We'll see how to create both an outbound as well as an inbound adapter code. And we'll get a demonstration of creating that custom adapter. Then we'll talk a little bit about how adapters can publish metadata through both a browsing mode and a search mode. And you'll see then how to implement that within your custom adapter. When you install the WCF Line of Business Adapter SDK, one of the things you'll get is a Visual Studio Adapter Project template. This allows you to get a jump start on writing your adapter code by walking you through a wizard, collecting some key information. The project generates for you a .NET library with a lot of the configuration details you supply through the wizard already in the code or in the configuration. And this enables you to get started right away on writing the logic and the interface between WCF messages and your system. Now, it'll also add the appropriate references to the Microsoft Service Model Channels DLL and stub out, as I said, all of the interfaces so that you get to jump right into the implementation and focus on the details of interacting with your system and not all of the infrastructure of creating all the right classes and getting everything set up initially. One of the key things when you specify your adapter is that both clients and listeners are going to use some sort of a URI to identify an endpoint. You need to have a way to uniquely address your adapter or your system. And so you can see here we've got an example of HTTP where we've got even a username there in the URI and the server name and port, the virtual address, and any parameters. But you determine the URI scheme, that first part. HTTP is a scheme, or net.tcp, as shown down in the bottom, are schemes. So you need to identify what is your scheme going to be, and then what do you need within the URI in order to be able to talk to your line of business system or database. Do you need a host name? Do you need a port? Is there additional path information you need to help you uniquely identify? So for example, do I need a server name and a port that maybe a particular database system is listening on? And then the path might include information such as the database name or a schema within the database. You need to decide what is it that I need from that connection info in order to be able to uniquely identify the system that I'm going to connect to and any additional information I need to connect. Another responsibility when you write the adapter is that you need to manage the connections. Now you have a couple of classes for this. We have a connection factory that gets generated by the wizard that parses that URI, and it really provides the container for all of the various properties that your application code is going to need, or your adapter code is going to need. The factory is responsible for creating connections, and those connections then get created for each instance of the handler, and they may or may not actually encapsulate a particular connection to your target system. So it may be that it contains each connection contains a SQL connection or a database connection or a port open to, or socket open to your system. But it's also possible that you would implement some sort of pooling or other things inside your adapter code. Now the connection itself doesn't really provide you a lot of data. It's that connection factory that's going to provide you all of the connection properties and provides that central location for the information you need in order to connect. The connection is really meant to represent a connection to the system. The adapter object, another class that gets created for you by the template, gets passed down and provides a lot of the adapter's configuration settings. So you're going to have connection information, but you're also going to have adapter settings such as, do I want to flow transactions? Do I need to enable sessions? Those sorts of things that would apply to any of the connections that you got, regardless of the URI. And those things, when we configure this, are represented as part of a custom binding object, which is a WCF configuration detail. When you go to create your outbound adapter then, you're going to write a class or implement the class that's already there. That's the outbound handler. Those outbound items really receive messages from WCF and then need to take that message and call out to your line of business system. So a WCF client can call your outbound adapter like any other WCF endpoint. The adapter gets that message from WCF through the SDK, and then it takes that message and talks to the line of business system or database, does all the appropriate work, and if appropriate, sends back a reply indicating the response message as a WCF message. That'll then pass back up and go to the client, who can then handle it through the WCF interfaces. Now you can write your handlers as either synchronous or asynchronous. They're set out as separate classes, and so depending on the kind of channel that you set up and the way that you configure that, you've got options as to how you want to do that. And some of that is set up for you through the wizard. So you can see here what the consumer of your adapter is going to look like. They're going to create the instance of your binding. They're going to create their request channel, which is essentially their generic interface to call your adapter. And they're going to have an endpoint address that would include your schema and your URI information in terms of server names or ports that you might have. We create a message, and then we would call on that channel passing in the message. That'll then go down through the binding, which will include your adapter code, and any response message would come back to the client. For inbound handlers, you're essentially going to be listening. So that inbound adapter code is going to be focused on listening to some physical location or listening for events, connecting up to your line of business application and listening for events. Or it may use a polling mechanism to go out and call your system periodically and look for new data or look for messages that should be submitted. So when the listener receives a message, its job is to receive that data, turn it into a WCF message, and pass it up to the channel listener layer, which will then ultimately indicate to the code that created this listener that a message has arrived. To create the inbound adapter then, we implement the inbound handler, and this is going to provide that listener capability in that event-based or listening or polling-based model. And the framework is going to let you know or let your code know when it's time to do things. So it will call start listener, and that lets you know that you should asynchronously go out and begin the process of listening for messages. A host process has created the hosting code for your inbound adapter here, and it wants you to start listening for messages. And then there's a couple of other methods. There's one called wait for message, and that is where you're going to be able to return true once there's some message to process. So periodically the framework's going to ask your code if there are any messages to process. Once you return true, then the try receive message will get called, and you'll be able to return any messages that you have. Now, luckily, this will get called repeatedly, so if you happen to grab a whole stack of messages, this will continue to get called until you have none to return. And ultimately, when that host or that code that wants to listen shuts down, you'll get called in your code to stop listening on that line of business system, and everything can shut down cleanly. In this demonstration, we'll see how to use the Visual Studio Wizard to create an adapter project. We'll see some of the generated code that gets created, and then we'll implement the connection URI class and the async outbound handler. We'll see how to deploy and test the adapter then with some client code. This demonstration will take a look at creating a new line of business adapter. Let's start a new project in Visual Studio 2010. And as I look under here, under Visual C#, I've got my options over here. I can sort these by name. And so I can see down here the WCF line of business adapter. I'm going to give this a name of demo adapter. And for now, we'll put it in C temp. And the whole point here is I want to show you how the wizard works and to walk you through what you get with the wizard to create an adapter. Then we'll switch over and look at a completed adapter so you can see the implementation and not have to watch me type. So as we begin the wizard, it first wants to know the scheme we're going to use. So we're going to give it a particular scheme here that we want to use. And for the namespace, we'll simply enter Northwind. Now you can see down here it's given a service namespace. We could check the box and override that if we wanted to with our unique namespace down there. We'll accept the default for now. And we're going to get the ability here, we could just select all. What we want to do is dictate what the adapter wizard is going to create for us. And so we want it to create both asynchronous and synchronous and inbound and outbound handlers for us so that we can implement operations that do both inbound and outbound. And we also want to support both models of search, or both models of metadata here through the browse and search. Now the next step is the adapter properties, and this is going to allow me to specify higher level properties. So I could do something like a cache duration in minutes. We'll say it's an int32, and I'll say that the default value is 20. These are properties that are going to show up on the binding. That'll show up in the binding properties of the dialog. That'll allow me to configure aspects of the adapter itself that I'll use across connections. Now the connection properties are going to allow me to specify those items that are going to be part of my URI and part of my connection. We'll call that a string. So that's my data directory that I want, and I want to add that as a string, and we'll add that in as well. We're not going to provide a default value for that one. As we get to the end, we can see all the different pieces that are going to be generated for us, and we'll kick off the Wizard's code generation. Now, don't be intimidated by this first view here. There's a lot of code generated for us. The good news is, if we got our properties in there right, we won't have to touch a lot of it. But you can see the things that we've talked about, where we have the binding itself, we have connections and connection factories, we have the different metadata handlers, and the runtime handlers as well. So if we look in this project, and we go find the adapter binding element, we can see that we have a property on here called cache duration min, and that's a configuration property. So that's something that's going to be read out of the configuration file. See, it also took our default value and put it in there as well. So that wizard really helped us out by giving us these generated properties now that are available on the binding element that can be configured through the code or the configuration file. We've also got this helpful little class down here called demo adapter trace. If you look in there, you'll see that it just provides a static here property of this adapter trace that you can get back, and you can use that then to go out anywhere in your application and write trace statements out to any registered trace listeners, and they would then be able to collect up any of that trace information and send it off to the event log or an XML file or however that listener is configured to do so. Also got all these different handlers here. You can see there's a synchronous outbound handler. There's also an asynchronous outbound handler. If we go look at that implementation, you'll see that we have both an execute as well as a pair of begin and execute asynchronous methods. So we can do the synchronous invocation or we could do the asynchronous. And also notice that these are programming against the message object. Now the message object is a class that is in the WCF namespaces in the WCF framework itself, and that's what we would program against here in our model. WCF is going to hand us that message. We're going to need to process it and do things with our line of business system, and then we also need to hand back a message object so it can get processed correctly by WCF. Now let's take a look at an existing solution. We'll go in and see the implementation of a few of these classes. So this is going to look pretty familiar. It's similar to what we just generated, but it's actually been flushed out and created. So let's go down and look at the connection file here. So you can see here we've got the iConnection interface. So this is responsible for opening and closing connections and for validating. So we can see here on the isValid, it's going to look at the URI and it's going to make sure the directory, the data directory we gave it exists to indicate whether or not a connection is valid, whether or not the files that this particular adapter is going to look for are there. Now in this case, we don't have to do anything to physically open or close the connection. We can also see in our connection URI class, we take a look here in the constructor, we've created that. We've got the custom properties through our data directory. And we also have this when we go out and it creates a new URI here. When it gets that, it's going to take the scheme that we've provided and it's going to take that plus the data directory and return that. And it can also take the URI in and set the data directory here. Notice that it's simply getting the absolute path. So it's going to take off some of the scheme information. It's just going to take that path information and set it into the data directory. We've got our custom fields here that were generated for us by the wizard. So that class is responsible for the parsing and managing of those URIs and pulling out the specific properties that we care about and also putting them back together with the appropriate scheme so we can create a URI. Now let's go take a look at that async outbound handler. We'll take a look at the execute method. And in this case, it's a very simple implementation. We're going to take a look at the message headers action. So we're going to take a look at that message coming across. It has a headers collection, just like a SOAP message. In this case, we're going to look at the SOAP action, or the action that's going to indicate what operation we're trying to call. So if we try and call get discounts, then we're going to go out and create a discount message as the response. So that's going to be responsible for going and getting the discount listing and creating a message and sending that back. And if the operation they're invoking is get surcharges, we'll do the same thing for the surcharges. So you can see each of those down here. It's going to use that connection factory to get the URI. And it's then going to combine the data directory from that URI to go find the surcharges file. From there, it's just some X element parsing to create those things, read through, and then we're going to create a new message. So WCF, the message class itself, has a static create message, and we'll pass in then an XML reader over that XML that we pulled out and created it to create our message. Same thing with the create discount list message here. So we've got our connections, we've got our implementation of our outbound handler here. One of the things to be aware of is that once we've created this application, we have to deploy it. And so if we go to the properties for we look at the signing, we'll see that this assembly has been signed with a strong name key, and that's a requirement for these adapters because you're going to have to deploy it to the global assembly cache and provide it in the central place where it's accessible by all applications. So that's one step, is we have to strong name it and put it in the GAC, but the other is we're going to have to update the machine config. So here you can see these additions that would be put into the machine config, and you may need to put it in your framework 64 directory as well if you're running 64-bit, where we add this binding element extensions in here. So that will likely already be present under your system service model configuration, and you'll just need to put this add here. We'll give it a name for the adapter itself. That's a binding element extension. And you can see then it's going to point to our Northwind LOB adapter, the core class, in this scenario. And we have the strong name key that's been generated, or the token for our strong name key is in there as well. We also have a binding extension, the Northwind binding itself, that can go in there, and it has a binding collection element. So we can, if we use a custom binding, we can add this thing in by ourselves. So again, the binding extensions, the binding element extensions probably already exist in your machine config, but you'll just need to copy and paste these adds in there, or as part of an installer package, more likely, you would include those things into the system. So I've got a couple of breakpoints set in here on our asynchronous outbound handler. We can see here, so as we get into those individual messages, so let's start up our test application, our client application. We'll debug through that. And as we call into the adapter then, we'll see these different invocations of the operations that we've defined through the adapter. So if we call get discounts, that's going to invoke the get discounts method on our proxy that was generated in a previous example. That's going to come in to create the discount list message. And we can see then that it's going to read that discounts file, create us that response message, and return that back. When we call get surcharges, now we've come into the get surcharge list message. Again, it's going to go out now and find the appropriate surcharges file, read from that file, or our line of business system, and build up the response message then to send that back. And we get those responses back out now on the other side. So in our case, we've used XML files as a store. You may be connecting up to a database and executing queries. You may be using an API to your line of business application and invoking methods on that API to go out and get the data or to go out and influence some change in your system. One of the key advantages of using the WCF Line of Business Adapter SDK over writing your own WCF service that's strongly typed and wraps your service is that it provides a framework for publishing metadata. That metadata can be static or it may be dynamic. You think about a database, for example. If I go look at the metadata today, it may be different tomorrow when you've added a new stored procedure or a new table. Likewise, if your line of business application, you need to expose certain data today, and tomorrow there's additional functionality that shows up, we want to have this framework in place to enable that metadata support going forward. Now in your adapter, you can publish searchable metadata, so you implement an iMetadata search handler, and this allows you to go out and implement the search method. So you'll get passed in any search criteria and scope information, and then you can go out and search against your APIs or search against your set of objects in your line of business app or database and return some results that specify all the different operations that might be available. There's also a browsing model where you can implement the iMetadata browse handler, and this allows somebody to click through a tree and drill down into various scopes and find things manually through browsing. So you could write the code that, again, based on the context, based on where in a particular tree they are, they're able to get back the appropriate metadata. In this demonstration, we're going to take a look at how to implement the browsing and the metadata resolving handler, and then we'll see consuming the metadata to see how that process surfaced the metadata up through that common user interface that we have from the SDK. In this example, we'll take a look at handling the metadata aspects of a line of business adapter. So what I've opened up here is my Northwind Adapter's metadata browse handler. This is a class that's responsible for responding when you're using the add adapter service reference, the SDK dialog, and you want to browse through the metadata. So we can see here in the browse operation that it takes in this node ID, a start index, and a max nodes, and we're responsible for returning this array of metadata retrieval nodes. And these are really just pointers, if you will, where we're just going to provide information about the operations that are available when browsing at this particular level. So as we go in here, we can say if the node ID is null or empty, or the node ID equals the root, right, so we're looking for everything, then we'll create a metadata retrieval node for the discount node, and we'll indicate an ID for that, provide a display name and description, indicate that it's an outbound operation, and we'll say is operation is false, which may be a little bit confusing, but discounts here, right, is the node that we want to list for the root. That's going to give us the categories, if you will. As we get down here and search, we'll see that we're under the discounts or surcharges. So notice the node IDs up here, discounts, surcharges, map to what we use down here. And so what we're doing is building up this tree. If you come to the root, we're going to give you the categories of discounts and surcharges. If you choose discounts or surcharges, we're going to go down and build up a set of nodes. In this case, we'll do a metadata retrieval node for the operations. So here we have get surcharges with its display name and description and direction. And now is operation is true, because this is something we want to show up in the list of operations. Now, once you've specified these things, these are going to be, again, the pointers of the information, then we're also going to have a class called the resolver handler. And the resolver handler has this resolve operation metadata. It also has the ability to resolve other type data. But you can see here that we're going to get an operation ID that is coming from that listing or that metadata that we just provided. And so we have the get charges operation or the get discounts operation. And in this case, our job is to return the metadata for that particular operation. So that if somebody has selected that and wants to include it in their set of operations that they're going to generate their proxy for, we need to provide the metadata to do that. Now, rather than have to generate metadata in the form of WSDL or WCF specific metadata, we use this abstraction, this operation metadata, to do that. So I can build the metadata for this getDiscounts method. I can say, well, it's a parameterized operation. I give it the name there in the description. I can give it an operation namespace. So this is going to influence the action that gets applied to it. And I can set the operation result. I want to say that I have this qualified type of string. And then the second parameter in here, if you look, is indicating that this is an array. So I'm saying I want to pass back an array of these particular items. We do the same thing for the build get surcharges metadata. So we browse, we find these things, and then for the individual operations, we have the ability to supply the metadata for those operations. In this case, we're saying that each of these returns an array of strings. So if we go to the client application and fire up our wizard here, I've indicated that I want to add an adapter service reference. Let's configure the URI here. We'll go into the C all files. We'll indicate demo code, module 16, and then connect. We'll go to the outbound operation. So notice here is our discount listings and surcharge listings. These are the first items we returned when we saw that route and we said they weren't operations. That forced them over here into the category. Now when I select a category, that's going to give me my operations, my list of operations. So here we're still in that browse handler where we've now gotten a new node specified by the discount listings. And when we've requested that node, we gave back those pointers to the operations. Now if I added this in, when I went to generate this then, it would call into my resolver and indicate that it needed the metadata for that operation in order to build essentially the WSDL and the metadata that we could use to build a proxy. So that enables the browse capabilities. If we come back in, we can see we also have a search handler. So here we create our metadata, our search handler. So it's iMetadata search handler. And we implement the search method. Oops, that's also going to take a node ID. So this gives us a category, or this gives us at least a context in the hierarchy at which we should search. So we know whether to search across certain categories or at a more refined level. We also get some search criteria and the maximum number of nodes we should return and a timeout. So if you've selected the discounts or the surcharges node, we're simply going to search across, in this case a very simple example, we're just going to get you all the discount nodes. Or if you're in the surcharges and you filter, we'll get you the surcharges. You'd want to take that search criteria obviously and based on your API try and filter down the list to just those that matched. But in this simple case, we just wanted to show you the basics of the API. Now if you aren't at either of those levels, you must be up at the root, and so we'll take both the discounts node and the surcharges node and union those things together to give you all the results across those two. So now if we go back to our client application and we fire up the wizard again, we can connect. So if we go to the discount listings here and we type anything in under here to list, notice that we're only going to get the items that are under that particular category. But if we come up to the root and we search and do list, now we get list discounts and list surcharges. So when we're at this root level and we search, we get everything. We're going across the different categories. Whereas when you drill down to a given category or node in there, then when you search, you're only going to find items within that category. And you can see up here at the top where it says searching category what that scope is that you're operating under. So we have the metadata browsing, where we create those categories and those list of operations. We also have the metadata search, where we can go against our API and find the matching operations, the matching set of things that someone may be searching for, and display those as well. It becomes really helpful when you have larger APIs with lots and lots of operations to be able to come in and search or filter those things down so you don't have to dig through a really long list to find the operation that you want. In our third lesson, we're going to discuss the BizTalk Adapter Pack. We'll talk about what the BizTalk Adapter Pack is and look at some of the line of business adapters that it includes. The BizTalk Adapter Pack is a set of adapters for some very common line of business systems. You can use it from BizTalk both on send ports and receive locations to talk to these line of business systems. And because it's built on top of the WCF line of business adapter SDK, you don't have to use BizTalk to talk to these things. So while you can consume these adapters from BizTalk, they're also available to .NET applications or SharePoint or other client applications. The license for these adapters, however, is included with your BizTalk server license, so there's no additional license to buy for the particular adapters. In version 1 of the BizTalk Adapter Pack, there was the MySAP adapter, an adapter for Oracle databases and Siebel databases, or the Siebel eBusiness rather. And in version 2, we had support for Oracle eBusiness Suite and Microsoft SQL Server. The SQL Server adapter replaces the old SQL adapter that was available since BizTalk 2004 and uses that new model, the WCF adapter SDK, to provide that rich metadata browsing and searching. Now, the other adapters here allow you to talk to the various systems, the Oracle, Siebel, and SAP. And in the BizTalk 2010 version, all of these have been enhanced and updated and work with the current BizTalk 2010 product. In the lab for the adapter framework, you'll see how to create a line of business adapter framework using the project. You'll implement both an outbound handler as well as a client to test that. And then you'll create an inbound handler and a listener that can listen on that particular binding and receive messages from your line of business adapter.